Hi everyone, I'm going to be going over question number 44 from the Chapter 8 Bingo Problems. Question 44 has to do with this little system here that I've drawn a picture of. It's a block connected to a spring that's connected to some sort of horizontal surface. The block is 15 kilograms, and what happens is this stone that has a mass of 3 kilograms moves at 8 meters per second and strikes this block. We're also given that the spring constant of this spring here is 500, which is useful. And then we also know after impact, the stone rebounds left at 2 meters per second. And wants to know the max distance the spring compresses during this situation. So the game plan for this is to first use momentum and then use energy. So for momentum, we know that momentum is going to be conserved in this. And so we know that the mass of the stone, so the momentum of the stone plus the momentum of the block, that's great, is going to equal the mass of the stone final plus the final block momentum. And so what we're looking for is we want to find the final velocity of the block. And so to do that, we can just rearrange our equation, and we'll end up with, well, first of all, so the block is at rest initially, so this whole part we can just get rid of, which kind of helps us out a little bit. So now what we'll do is we'll solve for the final velocity of the block, and we'll end up with So here's what we end up with. So now what we need to do is plug in our values to find what this variable is. And so when we do that, we get mass of the stone, 3 kilograms, times the initial velocity of the stone, which is 8 meters per second, minus the mass of the stone again, times the final velocity, which is going to be -2. And then the mass of the block is 15 kilograms. When we work this out, we get V final is equal to 2.0 meters per second. So I'll write that up here. So we'll need to use that later. So now that we've figured that out, we can use our energy equations. So we know that the kinetic energy of the block can equal 1/2 the mass of the block, V squared. So that's our final kinetic energy of the block. And then we know that the potential energy of the spring, we'll just say US for the potential energy of the spring is equal to 1/2 K, oops, man, I'm writing all the wrong things, 1/2 KX squared. And we can set these equal to each other. So what we'll end up with is 1/2 MBVB S squared equals 1/2 KX squared. And now what we need to do is we just need to solve for x, because that's going to be that displacement of the spring. And so when we do that, we end up, first of all, we can cancel out these halves, which is nice. But we'll end up with x equals the square root of mb over k, all in the square root, and then times the final velocity. And that's why we need to define that with the momentum, because we need that value to find x. And so now what we'll do is we'll just plug everything in. We already know everything else. So we know that x is equal to the mass of the block, which is 15. The spring constant is 500. And then times, we know that our final velocity at B is 2 meters per second. Multiply that, and we'll end up with x equaling 0.35 meters. So that means with this whole situation, the max amount that spring is compressed is 0.35 meters. So as a little kind of summary, we used the conservation of momentum, and then we also used our energy equations together to be able to find that displacement of the spring with this system. So it's kind of a fun problem because we don't only use momentum, we don't only use energy, we use both together. But anyway, I hope you learned something, and I will see you in the next video. Thanks for watching.